Sometimes when you're working with formulas, they can get kind of complicated, like this one right here. All sorts of exponents going on here. And you might have a question, not of how do you solve this entire formula, but you might just have a question that says, if you double one of the variables, what happens to the value of the entire fraction? So I'll give you an example. What's going to happen if we double the value of b? What will be the effect on a? So if you look at this in detail, let's turn this, instead of b, let's turn that into 2b. So I'm going to say I still have my 4. I'm going to have 2b inside the parentheses, that's cubed, times c, divided by d to the negative 1 and e squared. So what's the effect going to be? Well, as you simplify this, you'll see that 2b cubed, if you remember, is just 8b cubed written like this. And the reason that's happening is because when you do 2b cubed, remember what that means. That means 2b times 2b times 2b. Okay, and that's 2 times 2 times 2 times b times b times b. So you get 8b cubed. So that's the situation on top. Nothing has changed on bottom. And now I'm just going to rearrange this a little bit to take that 8 and move it out to the front. Remember, it doesn't matter what order you multiply things together in, so you can get away with stuff like this. So if you look at this equation now as I finally rewrote it, what is the only difference here? It's this number 8 out front. So you see the effect of doubling b was to octuple, or whatever, multiply the entire value of this thing by 8 right here. Okay. I didn't need to look at c, I didn't need to look at d or e or any of the other variables or numbers. All I need to look at is the exponent on the variable that I'm doubling. So if we were to do this, for example, with c, if you look at the exponent on c, that's just a 1. So if I double c, it's going to double the entire thing. It's not going to quadruple it. It's not going to multiply it by 8. It's only going to multiply it by 2 because it has an exponent of 1. So there's no interesting effects there when you double c. If you were to do something a little more interesting, let's try one of the variables on the bottom. Let's try cutting them in half, for example. Let's take the value of d and cut it in half. So what's going to happen here is, let me write it out. I have 4b cubed c divided by, and now instead of d, I'm going to say 1/2 d to the negative 1 e squared. And as we simplify this, we have to remember what a negative exponent means. First, let me just split up 1/2. So I'm really talking about 1/2 to the negative 1 times d to the negative 1 times e squared. So really the only thing that I'm focusing on is that 1/2 to the negative 1. Well, if you remember what 1/2 to the negative 1 means, negative 1 just means flip something over. If you have any exponent, like I'll give you an example, a to the negative 1, what is that? That's 1 divided by a. Or 1/3 to the negative 1, what is that? Well, you flip it over, you get 3, or 3 over 1, which is just 3. So what this turns into is 4b cubed c over 2d to the negative 1 e squared. Now before you say, aha, that's it, I must have doubled my problem, look at where that 2 is located. It's on the bottom, which means you really just cut this fraction in half. Okay, so having the value of d had the effect of dividing the whole thing by a factor of 2. So be careful whether the variables are on top or bottom, and pay close attention to what the exponent is on them. That's going to tell you what the effect is on the total equation.